What if progress is not only about what we invent, but also about what quietly slips away? The story begins not with a single moment, but with a pattern, one so subtle it often goes unnoticed. Across decades, across laboratories and workshops, ideas have appeared that promise to change how we live. Stronger materials, cleaner systems, smarter designs. They arrived not as revolutions, but as gentle alternatives, simpler, more humane ways of doing familiar things. And then somehow they faded. Imagine it standing in a room filled with unfinished prototypes. A car body grown from plants, a light that never needs replacing, streets once threaded with electric rails. These are not fantasies. They were real enough to be built, tested, admired. Yet today, most of us have never heard their stories. This documentary is not about villains or secret cabals. It is about tension, the quiet friction between innovation and inertia, between what is possible and what becomes permanent. History, after all, is not only written by victors, it is shaped by systems that reward familiarity and punish disruption. Progress rarely moves in a straight line. It meanders, hesitates, doubles back. And sometimes it stalls not because an idea failed, but because it succeeded too well, too early, in the wrong context. In the early 20th century, optimism hummed through workshops and factories. Electricity promised abundance. Chemistry hinted at miracles. Engineers believed durability was a virtue, efficiency a moral good. Objects were built to last because scarcity was still a living memory. Then something shifted. As industries scaled and markets expanded, longevity began to look like a liability. Systems optimized for growth required consumption to keep moving. Replacement became more valuable than repair. The ideal product was no longer the one that endured, but the one that returned customers again and again. This shift did not announce itself with speeches or headlines. It crept in through standards, incentives, habits. It felt reasonable, invisible even. The ideas that didn't fit this rhythm often struggled, not always crushed outright, sometimes simply starved of attention. Research funding dried up. Regulations grew complex. Alternatives were labeled impractical, inefficient, or premature. The world moved on, and the ideas stayed behind. Yet their absence left a trace. Look around today. The waste that piles up faster than we can process it. Cities shaped around congestion rather than connection. Products designed with expiration dates baked into their bones. None of this happened overnight. It emerged from thousands of small decisions, each one logical on its own. The question is not whether different paths existed. They did. The question is why we forgot them. This series explores 10 moments when the future briefly took a different shape. Not to accuse, but to understand. To listen carefully to the places where curiosity met resistance, where imagination brushed against the limits of economics and habit. Each chapter will begin with a scene, a lab bench, a factory floor, a city street, and unfold into a larger reflection. What did people see then? What did they hope for? And what does it mean that we rarely tell these stories now? Because buried within these forgotten paths is something deeply human. Our struggle to balance comfort with courage, profit with purpose, speed with wisdom. Progress is not just about invention. It is about choice. And the choices we don't remember may shape our future as much as the ones we celebrate. So let us begin, not by asking what was taken from us, but by asking something quieter and perhaps more unsettling. What possibilities have we learned not to notice? It started with a car that didn't need gasoline. In 1979, a quiet man named Tom Ogle stood before a modified Ford Galaxy and claimed it could travel over 100 miles on a single gallon of fuel. No hybrid motors, no external batteries, just a reworked fuel delivery system that vaporized gasoline before combustion, dramatically increasing efficiency. He called it the Ogle fuel system. Crowds gathered in El Paso, Texas, where Ogle demonstrated the vehicle in real-world conditions. Reporters were astonished. Engineers were intrigued. He filed patents, gave interviews, and spoke of revolutionizing transportation. At just 24, he was poised to disrupt one of the most powerful industries on Earth. But within 2 years, Tom Ogle was dead. The circumstances remain murky. Officially, it was a combination of prescription drug interactions. Unofficially, speculation grew about pressure, intimidation, sabotage. His invention vanished from the public stage. The car disappeared. The patent sat dormant. And the world returned to its familiar rhythm of combustion and consumption. What really happened to Ogle may never be known. But what matters more is what his story symbolizes. His design wasn't magic. It leaned on known principles, how vaporized fuel burns more thoroughly, producing more energy with less waste. Internal combustion engines, as traditionally built, leave much potential untapped. Engineers had explored similar ideas before and since, but scaling them, standardizing them, supporting them. That would mean challenging a deeply entrenched system. Fuel efficiency, at scale, changes everything. It shortens supply chains, shrinks demand, disrupts profits across refineries, transport networks, and maintenance services. When an entire economy is built on throughput, even small improvements can feel like existential threats. In interviews, Ogle didn't seem like a man with illusions of grandeur. He wanted a better way. He spoke with the humility of a mechanic and the conviction of someone who saw unnecessary waste and dared to fix it. But good intentions don't always protect against powerful resistance. Over time, his story drifted into urban legend territory. Conspiracy theorists co-opted his name. Skeptics dismissed the whole thing. Yet somewhere in the middle lies a deeper truth about how innovation lives or dies not by its merit alone, but by the environment into which it's born. How many such ideas have we forgotten, not because they failed, but because they succeeded in the wrong economy? In Ogle's case, the physics may still be debated, but the cultural pattern is clear. A promising alternative emerges. It challenges the norm. Then, suddenly, silence. What if we didn't dismiss these stories as anomalies? What if we treated them as signals, faint but persistent reminders that the world we inhabit is not the only one possible? Ogle's car was not just a machine. It was a question rolling down the highway. What if we already found better ways, but simply didn't know how to accept them? In the spring of 1986, Stanley Meyer took a sip of cranberry juice and collapsed. The inventor had been dining with 2 potential investors in a restaurant near Columbus, Ohio. Moments before his death, he reportedly ran into the parking lot clutching his throat, exclaiming, "They poisoned me." The cause of death was ruled a cerebral aneurysm, but the story didn't end there, because Stanley Meyer claimed to have done something extraordinary. He said he had invented a car that ran on water. More specifically, his water fuel cell supposedly split water into hydrogen and oxygen using a low-energy process, then combusted the hydrogen to power an internal combustion engine. According to Meyer, his system required only a small amount of electricity and could run a dune buggy across the country using nothing but water. The promise was dazzling: limitless fuel, 0 emissions, total independence from oil. Meyer attracted attention: local press, fringe science communities, curious entrepreneurs. He spoke with certainty, often invoking patriotism and environmental urgency. Patents were filed, demonstrations were held. The U.S. Department of Energy took notice, but just as quickly, criticism arrived. Scientists questioned his claims. They pointed out that splitting water requires more energy than it yields, according to established physics. In 1996, a court ruled that Meyer had committed fraud after failing to provide credible evidence for his device's functionality. And then, 2 years later, he was dead. To this day, the debate rages in niche corners of the Internet. Was Meyer a visionary whose work threatened powerful interests, or a deluded tinkerer convinced of an impossible dream? The truth may lie somewhere in between. Stanley Meyer was not the first to dream of water as fuel. The concept has fascinated inventors for centuries, precisely because of its simplicity and abundance. But water is stable. Breaking it apart takes energy that must come from somewhere. So when someone claims to do it with almost no power input, the scientific community demands rigorous proof. And yet, something about Meyer's story lingers. Not the specifics, but the symbolism. We live in a world of scarcity, where energy is hoarded, metered, and traded. The idea that fuel could fall from the sky, rain, rivers, oceans, is not just radical. It's destabilizing. It challenges the very foundations of industrial economies, energy monopolies, and geopolitical strategies. That's why stories like Meyer's, whether true or not, resonate. They express a yearning for liberation from systems that feel immovable. They hint at a hidden abundance just out of reach, not because it's impossible, but because it doesn't align with how we currently measure value. Meyer's car, like Ogle's, became less important for what it actually did and more for what it represented, a glimpse at how different things might be. Sometimes the mere suggestion of another way is enough to shake the ground beneath the status quo. So perhaps the real question is not whether Stanley Meyer was right or wrong. It's why, even decades later, so many people still want him to be right. What does it say about our world that the dream of running on water feels not just hopeful, but necessary? Beneath the streets of many American cities, the past still lingers, buried under layers of asphalt and time. Once the clatter of electric streetcars filled the air. They ran on tracks powered by overhead wires, weaving through neighborhoods, connecting people across town. Silent, clean, and efficient, these systems were the lifeblood of urban life in the early 20th century. And then, almost overnight, they vanished. What replaced them was a curious pivot. In city after city, electric trolleys were bought out, dismantled, and replaced by fleets of buses, many operated by companies with ties to oil and automotive interests. This was not simply a case of changing tastes. It was a coordinated shift in transportation infrastructure, known today as the Great American Streetcar Scandal. In 1949, General Motors and several affiliated companies were convicted in federal court for conspiring to monopolize public transportation. Their strategy: acquire local trolley lines, scrap the electric systems, and introduce gasoline-powered buses in their place. The fines were minor. The impact was massive. At the time, buses were promoted as modern and flexible, but they came with consequences: more traffic, more pollution, and eventually the decline of public transit in favor of private car ownership. The urban landscape was reshaped not by necessity, but by corporate design. Today, many cities are struggling to rebuild the very systems they once tore up. Los Angeles, once home to one of the most extensive streetcar networks in the world, became a symbol of car dependency. Tracks that once connected communities now lie hidden beneath pavement or preserved only in photographs. What was lost wasn't just a mode of transport, it was a way of life. Electric streetcars were not just efficient. They were communal. They moved people at a human pace through spaces designed for pedestrians, not engines. Their disappearance helped usher in an era of isolation, suburbs, commutes, gridlock. This history isn't about nostalgia. It's about intention. Because infrastructure doesn't just happen. It's built around values. And when those values prioritize convenience for some over connection for all, the consequences unfold slowly, invisibly, until one day we forget things were ever different. The streetcar story is a reminder that progress can be reversed. That innovation alone isn't enough. What matters is what we choose to protect: and why. As we face new transitions toward cleaner energy, smarter cities, sustainable design, it's worth asking, what if the future we're trying to build was already here once? And what does it say about us that we paved over it in the name of speed? In the early 1900s, the future of electricity flickered between two competing visions. One was orderly, centralized, and profitable. The other was wild, wireless, and free. At the center of the second vision stood Nikola Tesla. To many, Tesla was a genius lost in time, a brilliant inventor whose dreams often eclipsed the era he lived in. Among his most ambitious ideas was the transmission of electricity through the air, without wires, without boundaries, and without meters. In 1901, with funding from financier J.P. Morgan, Tesla began building the Wardenclyffe Tower in Shoreham, New York. Officially, it was a wireless communications hub. Unofficially, Tesla dreamed of broadcasting electrical energy across the globe, power from the Earth itself, accessible to anyone with the right receiver. Imagine a world where homes, ships, and factories drew power from the sky. Tesla saw it. He built for it. But the money dried up. Morgan, upon realizing Tesla's vision offered no clear way to bill customers, pulled his support. Without financial backing, the tower was never completed. In 1917, it was demolished. Scrap metal sold to pay debts. Tesla died penniless in a New York hotel room, his notebooks scattered, many of his ideas dismissed or forgotten. Yet the implications of what he tried to build continue to haunt the imagination. Modern science still debates the practicality of Tesla's wireless power transmission. Some argue it was misunderstood. Others say it was ahead of its time. Today, wireless energy transfer exists on small scales. Inductive charging pads, experimental drones. But Tesla dreamed much bigger, not just about electricity, about access. Because energy, in his view, was not a commodity. It was a natural force, like air or sunlight, something that belonged to everyone. And that's what made his idea so dangerous. Centralized energy systems depend on control. Wires, grids, meters, all necessary to regulate, profit, and govern. A world where power flows through the atmosphere, untethered, challenges more than utility monopolies. It challenges how we think about ownership itself. Tesla's failure wasn't purely technical, it was ideological. He imagined a world built on abundance, while the world around him operated on scarcity. It's easy to romanticize Tesla as a misunderstood prophet, but perhaps it's more useful to see him as a case study in what happens when vision exceeds the structures built to support it. His story asks us to reconsider what we call impossible, because sometimes what's dismissed as fantasy is really a threat to the familiar. And the question that lingers isn't whether Tesla could have lit the world without wires, it's whether we were ready for the kind of world he imagined, and if we still aren't. It was a material stronger than steel, lighter than aluminum, and born from grass. In the mid-20th century, industrialist Henry Ford unveiled a car partially made from hemp-based plastic. In a now-famous photograph, Ford struck the trunk of the prototype with an axe, which bounced off without leaving a dent. The material was resilient, biodegradable, and could be sourced from renewable crops. The car ran on hemp-based biofuel, too. Ford believed that agriculture and industry didn't have to be rivals, they could be partners. Why use up the forests, he asked, which were centuries in the making, and the mines which required ages to lay down, if we can get the equivalent of forest and mineral products in the annual growth of the hemp fields? Imagine building homes that breathe, insulate, and endure, made not from concrete or steel, but from something as humble as hemp. Long before the push for sustainable living, ancient cultures used hemp mixed with lime to create a durable building material known today as hempcrete. Lightweight, fire-resistant, pest-resistant, and with excellent insulation properties, Hempcrete also sequesters carbon, locking away CO2 as it hardens over time. In France, it's been used for centuries. In recent decades, architects and engineers around the world began revisiting its potential, not just for eco-friendly homes, but as a serious response to climate change, rising construction costs, and housing shortages. Yet in many places, hempcrete remains niche. Part of the reason lies in regulation. In the 20th century, sweeping bans on cannabis, driven more by politics than science, lumped industrial hemp in with its psychoactive cousin. Decades of prohibition stunted agricultural development, research, and public perception. Even when laws began to shift, stigma lingered. And then there's the scale. Concrete and steel are backed by massive industries with deep roots. Their supply chains are global, their methods standardized. Hempcrete, by contrast, often requires local sourcing, smaller operations, and a change in how we think about building altogether. This isn't just about material, it's about mindset. Hempcrete buildings tend to last longer, require less energy to heat or cool, and create healthier indoor environments. But they don't fit easily into the profit models of fast construction and frequent turnover. They're too slow, too sustainable, too sensible. So despite its clear advantages, hempcrete remains an underdog, a solution waiting for the right moment to be embraced. That moment may be approaching. As the environmental cost of modern construction becomes harder to ignore, interest in regenerative architecture is rising. Cities are experimenting. Designers are dreaming. And hemp, once criminalized, is quietly returning to the fields. Still, adoption is slow. Not because the material isn't ready, but because the system isn't. What we build reflects what we value. If we prioritize speed, we get buildings that crumble. If we prioritize longevity, we must accept methods that take more time, more care, more patience. Hempcrete teaches us that some solutions aren't flashy. They're not disruptive in the Silicon Valley sense. They're just wise. And wisdom, in a world addicted to acceleration, often goes unheard. So the question remains. In an age of collapsing ecosystems and spiraling costs, will we continue to build the future with materials of the past? Or will we listen to what the earth has always offered and start again from the ground up? In the dim corridors of early 20th century science, one discovery glowed, literally. Wilhelm Reich, an Austrian psychoanalyst and former student of Freud, believed he had found a new form of energy. He called it Orgone, a universal life force, he claimed, present in the air, in the body, in the cosmos. Reich saw it as a bridge between biology and the atmosphere, a missing link between emotion and matter. To harness it, he built devices called orgone accumulators, box-like chambers layered with organic and metallic materials. Patients sat inside. Some reported feeling invigorated, emotionally released, even healed. Reich believed the technology could treat everything from depression to cancer. The medical establishment was not impressed. To many, orgone was pseudoscience. The terminology was vague, the mechanisms unprovable. Reich's writings mixed physics with psychoanalysis, cosmic theory with sexuality. By the 1950s, the U.S. Food and Drug Administration moved against him. A federal court deemed his devices fraudulent and ordered them destroyed. Reich was imprisoned for contempt of court. In 1957, he died in his cell. His research materials were burned, his equipment dismantled. His name became a cautionary tale, and yet interest never fully disappeared. Today, orgone energy lives on in fringe communities, alternative medicine circles, and underground experiments. It's often dismissed, sometimes mocked. But beneath the eccentricity lies a deeper question. Why do we react so strongly to ideas that don't fit our frameworks? Reich was not the only thinker to blur the boundaries between science and spirit. Many early pioneers, Kepler, Newton, Faraday, dabbled in mysticism, alchemy, or metaphysics. But Reich arrived in a century increasingly defined by control, regulation, and scientific orthodoxy. His crime, perhaps, was not deception, it was imagination. He tried to name a force science had no place for, to give language to something felt but not measured. In doing so, he threatened the boundaries of accepted knowledge, and those boundaries, once drawn, are rarely kind to trespassers. This is not a defense of Reich's theories. It is a reminder of how history selects which questions are worth asking. Orgone may not have been real in the way Reich imagined, but the need it tried to address, our hunger for connection between body, emotion, and environment, remains unresolved. What if science had found a gentler way to engage? To test, refine, challenge, but not erase? And what other ideas, dismissed too early, might have held threads of truth? Sometimes we burn books not because they are wrong, but because they ask us to rethink what right means. And in that ash, something vital is lost, the courage to wonder beyond the visible. What does it cost us as a species to silence the strange too quickly? What if light could be trapped, shaped, and guided without wires, heat, or moving parts? In the 1980s, a quietly brilliant engineer named Marcel Vogel made waves at IBM with his work in magnetic coatings and data storage. But outside his corporate accomplishments, Vogel harbored a fascination that veered far from the mainstream: the energy properties of crystals. Vogel believed that quartz and similar minerals could store, focus, and even transmit energy in ways conventional science had yet to grasp. He claimed to have built devices that converted subtle energies, thoughts, emotions, intentions, into measurable effects. Some of his lab work hinted at changes in water structure influenced by human consciousness and channeled through specially cut crystals. He called it luminescence technology. To his peers in industrial science, Vogel's later work bordered on mysticism. But unlike many fringe theorists, he documented meticulously, experimented rigorously, and refused to charge for his discoveries. He believed the knowledge belonged to everyone. His lab became a strange intersection, part Silicon Valley, part alchemical workshop. Vogel crystals, cut in precise geometries based on sacred geometry and quantum resonance, are still produced today, not as gadgets, but as tools for meditation, healing, and subtle energy work. Many dismiss them, others swear by them. What fascinated Vogel wasn't just the physical material, it was the interaction between matter and mind. He asked whether consciousness could be a force, not just a byproduct, whether intention had shape, whether water, life's most essential substance, could be imprinted with memory. These questions remain controversial, even heretical, in mainstream science. And yet they echo growing research in fields like quantum biology, where particles behave in unpredictable ways, seemingly influenced by observation itself. Was Vogel wrong, or simply reaching too far, too soon? Science prides itself on skepticism, but sometimes that skepticism hardens into a gate, one that locks out not just fraud, but imagination. Vogel's legacy isn't just about crystals. It's about the courage to explore liminal spaces, those thin lines between disciplines, between known and unknown, where progress often begins. We often separate science and spirit, logic and intuition, but perhaps they're not opposites. Perhaps they're reflections of the same impulse, to understand our place in a universe that still withholds its deepest truths. Vogel once said, "Love is the glue of the universe." To many, that sounds poetic. To him, it was a literal statement of physics. And whether he was right or wrong, one thing is clear. He dared to ask questions that made others uncomfortable, not for fame or fortune, but for the sheer wonder of what might be. How many discoveries have we missed because we ridiculed the question before we tested it? In a dusty workshop outside of Buenos Aires, a soft-spoken inventor named Carlos F. Benitez unveiled a strange-looking motor. It didn't roar. It didn't hum. It pulsed, quietly, steadily, without a fuel tank, without heat, without conventional combustion. Benitez called it a free energy device, powered not by magic, but by tapping into what he claimed was an ever-present untapped force in the environment. He wasn't the first to make such a claim. For decades, inventors around the world have spoken of zero-point energy, the idea that even the vacuum of space holds fluctuating energy fields, ripe for extraction. Mainstream physics acknowledges the concept in theory, but insists the energy is not accessible, not practically, not yet. But the dream persists. Benitez demonstrated his motor in person. Journalists watched. Engineers scratched their heads. It appeared to run without input once started. No wires, no batteries, no trickery they could detect. Still, most walked away skeptical. No peer-reviewed studies, no large-scale tests, no blueprint that others could reliably reproduce. The machine faded into obscurity, like so many others before it. Here's the uncomfortable truth. Our world is full of unverified inventions that seem to bend the rules, and we don't always know what to do with them. Sometimes we dismiss them out of scientific rigor. Other times, out of fear. Fear of disruption. Fear of being deceived. Fear of hope. Free energy threatens the very scaffolding of modern society. Economies built on scarcity, power grids reliant on regulation, entire industries that function not by abundance, but by control. If someone could pull electricity from the ether, cheap, clean, infinite, what happens to the logic of supply and demand? That's why these stories often feel dangerous, even when unproven. They ignite something primal, the longing for liberation from dependence. Still, skepticism has its place. Scientific history is littered with bold claims that unraveled under scrutiny. But it's also filled with ideas once ridiculed. Germ theory, plate tectonics, black holes, now pillars of modern understanding. The line between breakthrough and blunder isn't always visible at first. So when someone like Benitez builds a motor that seems to defy expectation, maybe the better question isn't whether it works. Maybe the question is, what kind of world would we need to live in for it to matter? Because even if the machine fails, the hunger it speaks to is very real, a yearning for freedom, sustainability, and a future that doesn't depend on extraction. And if we can't yet reach the energy hidden in the fabric of space, maybe we can still reach the energy hidden in our willingness to believe that another way is possible. What if the real breakthrough isn't in the machine, but in the mindset it invites? In a quiet corner of 1930s Pennsylvania, an engineer named Royal Raymond Rife peered through a microscope unlike any the world had seen. It was his own invention, a revolutionary optical device capable, he claimed, of magnifying living viruses in real time, at a time when electron microscopes were still in their infancy and typically killed the specimens they revealed. Rife's microscope offered a living window into disease. But he didn't stop there. Rife believed that if he could see pathogens, he could also destroy them, using frequency. He built a device he called the Rife Ray machine, designed to emit specific electromagnetic frequencies tuned to the vibrational signatures of viruses and bacteria. His theory, just as a wine glass shatters when exposed to its resonant frequency, harmful microbes could be neutralized without harming surrounding tissue. By the mid-1930s, Rife claimed to have cured diseases once thought incurable: tuberculosis, cancer, even polio. Some doctors supported him. Patients offered testimonials. A 1934 clinic trial reportedly showed dramatic results. And then, like so many stories in this series, the silence came. Rife's lab was raided. His instrument seized. Collaborators recanted or vanished. Lawsuits ensued. His technology, never accepted by mainstream medicine, was eventually declared illegal for unapproved treatment. Rife died in 1971, largely forgotten by the scientific community. Today, Rife machines are the stuff of alternative health clinics and online pseudoscience warnings. The medical establishment labels them unproven, their efficacy unsupported by rigorous trials. And yet interest persists. Why? Because once again, the story isn't just about a device, it's about a possibility. What if illness could be treated not with invasive chemicals or surgeries, but with precisely tuned waves of energy? What if the body, at its deepest level, was more musical than mechanical? Rife's work emerged in an era when medicine was transforming, moving toward pharmaceuticals, standard protocols, and institutional control. Frequency-based healing didn't fit the model. It was too decentralized, too hard to monetize, too mysterious. And yet, modern research is slowly circling back. Pulsed electromagnetic field therapy, ultrasound-based cancer treatments, bioelectric medicine. The idea that energy can heal is no longer fringe. It's becoming fact, just not on Rife's terms. So was he a fraud, a genius, or a mix of both? Maybe that's the wrong question. Maybe Rife's story reminds us that science progresses not only by what it proves, but by what it permits itself to explore. That sometimes the boundaries between failure and foresight are drawn by time, not truth, and that the future of healing might still lie in vibrations we've yet to understand. What other harmonies of the human body have we silenced before they could be heard? At the height of the Cold War, amid rockets and Red Scare headlines, a quiet revolution was unfolding in the kitchen. In 1965, an inventor named James Lovelock, better known today for the Gaia hypothesis, created a device so sensitive it could detect airborne compounds at parts per trillion. It was called the electron capture detector. Originally designed for environmental research, it revealed something unexpected. The world was soaked in chemicals. Among the most pervasive were chlorofluorocarbons, CFCs, used widely in aerosol sprays, refrigeration, and air conditioning. Invisible, odorless, seemingly harmless. But Lovelock's detectors showed they were everywhere, even in the remote Antarctic air. At first, no one panicked, but two atmospheric chemists, Mario Molina and Sherwood Rowland, followed the trail. In 1974, they published a paper warning that CFCs, stable on the ground, drifted into the upper atmosphere where they broke apart ozone molecules. The ozone layer, the planet's natural sunscreen, was thinning, rapidly. Industry response was swift and hostile. Chemical companies pushed back, funding counter-studies, launching PR campaigns, questioning the science. The implications were staggering. Banning CFCs meant rethinking entire manufacturing processes. Billions of dollars were at stake. But the evidence grew undeniable. By the 1980s, a literal hole in the ozone was discovered over Antarctica. Public concern exploded. And in 1987, the Montreal Protocol was signed, one of the most successful environmental treaties in history. It phased out ozone-depleting substances across the globe. The atmosphere began to heal. But what's often forgotten in this story is how close it came to being buried. For nearly a decade, Molina and Rowland's warnings were ignored, ridiculed, or suppressed. Had the science been a little less precise, or the timing a little less urgent, the story might have followed a different arc, one of silence, not action. This wasn't about a single invention. It was about perception. We often think of suppression as an active conspiracy, but sometimes it's quieter, a fog of doubt, a flood of distraction, the slow erosion of urgency. Progress stalls not because of disbelief, but because belief feels inconvenient. The CFC crisis showed that science can reveal uncomfortable truths, but only if society is willing to listen. And it revealed something deeper, too. Our technologies are not neutral. They extend our reach, but they also carry consequences. The things we spray, cool, and discard ripple into the sky, into the cells of animals, into the lungs of future generations. We live in an interconnected system. Lovelock saw the Earth as one living organism, its air, water, and soil in dynamic balance. And when that balance tilts, the effects are profound. The ozone story ended in global cooperation, but how many other warnings have we missed, or are still missing? What if the real lesson isn't just about CFCs, but about how long it took us to believe what was already in the air, and what invisible forces, drifting above us now, are waiting to be seen? In a small California lab in the late 1980s, two electrochemists, Martin Fleischmann and Stanley Pons, made an announcement that sent shockwaves through the scientific world. They claimed to have achieved cold fusion. Fusion, the process that powers the sun, normally requires temperatures of millions of degrees. But Pons and Fleischmann believed they had triggered a similar reaction at room temperature using heavy water and palladium electrodes. The implications were staggering: limitless clean energy from a tabletop device. The press pounced. Headlines spoke of an energy breakthrough that could end the oil age. Laboratories scrambled to replicate the results. Governments watched with cautious optimism. And then, the collapse. Most scientists couldn't reproduce the experiment. Accusations of sloppy methodology, premature publicity, and statistical error filled academic journals. Within months, cold fusion became a punchline, an embarrassment. Pons and Fleischmann, once celebrated, were shunned. Yet the story didn't truly end there. In the decades that followed, a small but persistent community of researchers, rebranding the phenomenon as low-energy nuclear reactions, LENR, continued quietly experimenting. Some reported anomalous heat, unexplained reactions, unusual material effects. Nothing conclusive, but nothing entirely dismissible either. NASA, DARPA, and other agencies took occasional interest. Patents were filed. Private labs kept testing. But the stigma remained. Cold fusion had become scientific taboo. Why? Because it broke too many rules. If true, it would rewrite fundamental assumptions about nuclear physics, energy production, and thermodynamics. It threatened not just technical models, but economic ones. Fossil fuels, nuclear reactors, even solar infrastructure, all could be disrupted by a cheap, compact source of infinite power, so the very magnitude of the claim became its undoing. And yet the yearning never died. Because cold fusion wasn't just a hypothesis, it was a hope that nature might be hiding simpler answers. That the world's most pressing problems, climate change, resource scarcity, energy poverty, might have elegant solutions buried in the folds of overlooked science. But what do we do with hopes that science can't yet validate? We mock them. We marginalize them. We bury them under piles of polite disbelief. Not because they're wrong, but because we don't know how to fit them into the structures we trust. The cold fusion saga is a story of ambition, yes, but also of fragility. Of how one misstep can stain a whole field. Of how the gatekeepers of knowledge, in protecting truth, can sometimes wall off possibility. Perhaps cold fusion was a mistake. Or perhaps it was a glimpse of something deeper, something we simply weren't ready to see. And if so, what other answers lie waiting in failed experiments, half-remembered papers, and ridiculed minds? What if the boundary between science fiction and science fact is not time, but patience? The path through forgotten inventions leads us not just to what was lost, but to who we are. Every story in this series has pointed to a quiet truth. Human progress is not just built on what we create, but on what we allow ourselves to imagine, nurture, and protect. A car that sipped fuel instead of guzzling it. A tower meant to broadcast power through the air. Homes made of plants. Machines that whispered with frequencies. Energy that might hum beneath the vacuum of space. Each idea, whether flawed or brilliant, held a seed of potential. Yet so many were abandoned, buried not by failure, but by timing, resistance, or fear. The question we face now is not whether these inventions can be resurrected, but whether we've changed enough to receive them differently. The world has accelerated. Technology moves faster. Information spreads in seconds. But our systems, the invisible architecture of economy, policy, belief, often remain shaped by the values of a different age. And that creates friction. In a world designed for consumption, durability becomes subversive. In a market optimized for scarcity, abundance can feel dangerous. Innovation doesn't just need engineering, it needs ecosystems of support, courage, and cultural readiness. That's what many of these stories lacked. It's not that the ideas were too strange, it's that we weren't ready to ask, what if? What if power didn't have to be centralized? What if health didn't depend on chemicals alone? What if waste wasn't inevitable? What if healing, energy, motion, life itself could be reimagined? These aren't technological questions. They're human ones. Because buried inside every suppressed discovery is a mirror showing us our fears, our limits, our habits. And maybe that's why these stories still resonate. Not because we expect to build perpetual motion machines or heal with crystals, but because we yearn for the courage to rethink what's possible. The stories in this series are not just about what we've forgotten. They are about what we might still recover, if not the exact inventions, then the spirit behind them. Curiosity, openness, humility, wonder. These are the engines of real progress, and they are harder to preserve than any machine. So as we move into a century defined by crisis, climate, energy, health, meaning, we need more than innovation. We need imagination unbound from fear. Not every idea deserves to be believed, but every idea deserves to be heard. Because somewhere in the noise of dismissed dreams and broken prototypes lies the next path forward. Not a miracle, just a possibility. And perhaps the greatest discovery we can make is not in a lab or a patent office, but in the willingness to listen again, to question kindly, to remember that the future has always belonged to those who refuse to stop wondering. What might we rediscover if we gave ourselves permission to believe? Not in magic, but in the quiet resilience of the human spirit?